Surat, one of the cleanest cities of India, is also the most dynamic city of India with the fastest growth rate. Being an urban local body, Surat Municipal Corporation (SMC) caters to various services like water supply, sanitation, drainage, street lights and road development, etc. In the last decade of the 20th century, Surat has started to grow remarkably, and accordingly, SMC has constructed new capital projects, which has increased the energy bill of SMC at a faster rate. Being a visionary organization, SMC has realized the importance of energy and hence taken innovative steps of green power generation from sewage gas and to establish an energy efficiency cell dedicated exclusively for energy conservation activities. Sewage treatment plants are established for treating the sewage to prevent pollution of the surface and underground water. During the treatment process, sewage passes through various stages of treatment, such as inlet chamber, screen chambers, primary and secondary clarifiers, anaerobic digester, etc. Each unit has its own function. For green power generation, a sludge digester is important. The sludge digester is a closed-circuit RCC tank which reduces the volatile organic matters from the sludge by anaerobic digestion. Due to the anaerobic fermentation process, sewage gas is generated, which contains about 60 to 70% methane gas, which is used for power generation. The calorific value of sewage gas is from 4,700 kilocalories per cubic meter to 5,500 kilocalories per cubic meter. This gas was earlier burnt so that it is not harmful to the environment, and hence there was no use of this gas. SMC has taken the initiative in the project of utilization of sewage gas in power generation in association with MNRE way back in 1997 for Ajana STP, and afterwards a 0.5 megawatt power plant was proposed. This power plant was based on the use of an imported 100% sewage gas-based engine of Spanish origin, duly complemented with high levels of automation and a state-of-the-art polymer-based inflatable gas-holding balloon. The present generation of electricity from this plant is about 8,500 to 9,500 units per day, which is consumed to run the Ajana sewage treatment plant itself. Inspired by the successful operation of the Ajana biogas power plant, SMC took quick action and set up other 1 megawatt sewage gas power plants at Singanpur, Karanj and Bhatar STP. In a very short duration of 10 months, these projects have been commissioned in the year 2008. Renewable energy generation data are due to low gas pressure of sewage gas generated, gas extraction is done by the sewage gas collection blowers. The sewage gas is passed through H2S scrubber to reduce the level of H2S to prevent corrosion of the gas engine. As the gas generation rate of the digester is uneven, sewage gas is stored in a foil bag membrane type biogas holder. The sewage gas is fed through the sewage gas feed blowers at specific pressure to the spark-ignited sewage gas engine, which is connected with the alternator, and electricity is generated. As methane is a greenhouse gas which cannot be allowed to evacuate freely into the atmosphere, hence the excess gas is flared. Due to green energy generation, even though sewage water disposal has been increased, but conventional energy consumption has not been increased. The advantages are, it prevents free methane emission and reduces use of grid power, which in turn reduces global warming. Every day, 680 MLD water is supplied through the grid network of water supply. Grid network consists of the water treatment plants and water distribution stations. Raw water is collected from intake wells and filtered in the filtration plant. Filtered water is then transmitted to the water distribution stations and then fed to consumers. 20% energy of water supply system is consumed in transmission of water supply. Hence, in 2002, an extensive study of specific energy consumption for water transmission was undertaken with the help of energy audit data. Re-engineering Route 1. Umarwada Water Distribution Station WDS UGT's filling from Sirthana Water Works SWW. In the year 2000, Dumbhal WDS was receiving water from Umarwada WDS. Umarwada WDS was receiving water supply from Headwater Works, which was ultimately taking the water supply from Sirthana Water Works. In 2002, Dumbhal WDS has started to take water supply from Sirthana Water Works due to new transmission line laid. Hence, the pipeline between Umarwada WDS to Dumbhal WDS was not in use. In 2003, after due study, an innovative idea came that by making a connection between the existing pipelines, Umarwada WDS can be fed directly and double pumping can be avoided. Saving realized. In the same way, in re-engineering Route 2, Jogani Nagar WDS has been bypassed and Kathodara WDS and Athwa WDS are being fed directly from the Randeer Water Works. Saving realized. And in re-engineering Route 3, Pandesra WDS and Udhna WDS are being partially fed directly from Katargam Water Works by bypassing Kathodara WDS. Saving realized. Replacement of inefficient pump sets at Katargam and Sirthana Water Works has resulted in energy saving to the tune of 3.78 million kWh per annum. Also, the activities like contract demand rationalization, installation of thyristor-based APFC panels, trimming and coating of pump sets, etc. has been undertaken. Due to all of these activities, even though water supply quantity is increased from 478 MLD in the year 2003-2004 to 698 MLD in the year 2008-2009, specific energy consumption has been reduced from 344 kWh per ml to 292 kWh per ml. SMC has also taken energy conservation steps for street lighting, like the use of electronic ballast and high lumen tubes for all fluorescent fittings, and switching off 50% street lights on major roads during low traffic period. This has resulted in the energy saving of 42 lakh units per annum. SMC has adopted benchmarks of energy consumption for all energy-intensive sectors and has initiated means to reduce the consumption. SMC is committed to promote green power generation and energy efficiency to ensure sustainable growth and a better tomorrow.